Assalamualaikum warahmatullahi wabarakatuh. The topic for today is deformation of solids. So you're gonna see that this topic is the extension of what you have learned for force and also work. So the only difference for this topic is that you are gonna apply force. You're gonna apply force to an object that has definite shapes and volume, and the end product effect there, it's going to change its shapes and volume. So rather than previously, when you apply force, the object might tend to move, might tend not to move. But here, it simply changes the shape. Now, the sufficient, a very large force, will either be permanently deform it or break it. Otherwise, if it's able to return to its original shape, then we call this as elastic behavior. So we're going to see that in the terms of deformation, we have two situations. That if the force is large enough, then the object might not be able to return to its original shape. But if it's lesser than that, and it's able to return to original shapes and size, then this behavior is called elastic. So this is quite similar to the Fantastic Five. So the elastic properties of solids is discussed between two terms. Number one, stress. Number two is strain. So between the stress and the strain, they are proportional to one another. They are proportional to one another, where there is a constant. So this constant is called as elastic modulus. This elastic modulus, you will find that it's almost similar to what we call spring constant when we deal with force is equivalent to negative kx, quite similar to the idea. So in the idea of when force of a spring, or force is applied to a spring, and k is the spring constant, and x here is the amount of stretch or compress experienced by the spring.